Hello. So I thought I'd do a couple more integration examples. Now this example here is a problem from your book. It's an even number problem. It looks like it's problem 24. And I wanted to do this so you could see a couple of different approaches. Okay? Now sometimes there's more than one way to do it, and oftentimes one of the ways is much quicker than the other, but that's all right. That's all right. In this one, I'm going to start just with sort of a simple-minded approach and then try another approach and see if we can see how we could get this quicker. Okay? A simple-minded approach is, I noticed first that there are, two terms, right? When things are separated by an addition, I can just separate the integral. So let's just do this as two separate integrals. Again, this is just like a knee-jerk approach. I'm not thinking too far ahead. I'm just looking and seeing what it is I can do with this. I'm just going to look at these two terms separately. Okay, so, well, if you remember from class, if there was an odd exponent on the tangent, we would be all right, right? Or if odd exponent on a tangent and at least one secant, we'd be all right. We'd do a u equals secant x substitution. However, we have even exponents on both tangents, and the exponent on the secant, of course, is 0, which is, well, 0 is doable, isn't it? It seems like we should mess around and be able to get some secants here. Well, I look at this, I go, okay, tangent squared of x. Can I rewrite that? Does anybody remember what tangent squared of x is? This is one you should have down. Okay, that's going to be secant squared of x minus 1. And in fact, I can write this as tangent squared of x times secant squared of x minus 1. Okay, so that works. So let's do that. Let's do that. So let's get back to our pencil. So I'm going to write this then as secant squared of x minus 1 dx plus tangent squared of x, that's a squared, times secant squared of x minus 1 dx. And, well, of course, what's the benefit here? Well, what is the integral of secant squared of x? Let you think for a moment. Pause it, think. It's tangent of x, right? Because the derivative of tangent of x is secant of x. Integral of 1 with respect to x is just x. And let's separate this one here. Let's put that secant afterwards. Oops. Boy, that was an awfully big eraser, wasn't it? And, well, this, let's analyze what we have here. This we've already figured out, right? We wrote this as secant squared x minus 1, and we had the integral right there, right? This, well, look at that. We have 2 on the secant. So what are we going to do with that one? That one we're going to do a u substitution. U equals tangent x. So then du is what? Yeah, secant squared x dx. And so this is going to be tangent x minus x plus the integral of u squared du plus the integral of, oh, that's minus. Let me do a minus here. Minus the integral of, we were writing tangent squared of x as secant squared x minus 1, right? So that's secant squared x, well, dx minus the integral of dx. And so that's going to be tangent of x minus x plus, oh wait, that negative's got to distribute. Look at that, that's a plus. Remember, this is secant squared of x minus 1, and that negative distributes to both of those. So that becomes a plus there. Okay. So tangent of x minus x, and then the integral of u squared is u cubed over 3 minus, again, tangent of x plus x. Look at that. Plus c. And so that's going to be, well, the tangent x is canceled, the x is canceled. I'm left with u squared over u cubed over 3, so that's 1/3 tangent cubed x plus c. So it looks like the integral is just 1/3 tangent cubed x plus 3. Let's just check. Let me use a different color to check here. Check. One-third tangent cubed, the derivative of that, right? The derivative of this thing here is going to be, well, we got to use the chain rule. It's going to be 1/3 derivative of u cubed, which is 3u squared, times the derivative of u. Well, the derivative of tangent is secant squared. And of course, the derivative of c is just 0, so we can ignore that. Okay, so we want it to look like that. So let's change it all to tangents. Well, of course, the 3's cancel, and I get tangent squared of x times 1 plus tangent squared of x, right? Secant squared of x is 1 plus tangent squared of x. And lo and behold, that's tangent squared of x plus tangent to the 4th of x. Okay, so it checks. Okay, good. Okay, now I told you that sometimes if you look at things in the right way, you might see a better approach, right? And in this case, you might see it immediately. Often when things cancel, let me just point out, notice that this canceled with this. Often when you have a trig integral and things cancel, there probably was a better approach to it. I mean, once you're already done, why do it? Well, I'm going to do it just to, let's see if I can just copy this integral here, just to point out what things you can look at. So if I copy that and go down here and paste. Oh, beautiful. Let's okay. So let's try this again. So if I didn't separate the integrals, what if anybody see anything else? Of course, nobody's in the audience here that can talk to me. I'm going to factor out what I can. I can factor out a tangent squared. And what am I left with when I factored out when I factor out a tangent squared? Well, I'm left with 1 plus tangent squared of x. And oh, wow, what's 1 plus tangent squared of x? It is secant squared of x. And does anybody see here? Well, I've got an even power on the secant. Let's just point that out. I've got that wonderful even power on the secant. Undo. I meant to do a different color there. Okay, well, I didn't mean to undo that stuff, so I've got secant. I'm going to do a u substitution. So what should my u be here? U equal u should equal, of course, tangent x. So u equals tangent x. Du is then secant squared x. And and I go over here. Let me just point out what we have here. This together with this is my du, and I'm left with a u squared, right? And so this is the integral of u squared du, which of course is 1/3 u cubed plus c, which of course is 1/3 tangent cubed x plus c, which is exactly the same thing we got before. We already checked that answer.